Monday's lecture's up here. I need to be on this one. Monday's lecture is posted here. Okay. Tuesday is here. I posted the answer keys to these. We're going to go over these. Looks like this. I went over the odds in class. I said do the evens so we could go over them. Okay. Lost my spot. And then the quiz I sent you guys, the paper copies you guys have here. The quiz was from last week. It was this quiz. This one. Let me see if I can get in it. Quizzes. I have to go to quizzes. Well, I'll go there. We'll go there at the end. All right. So let's start by going over the evens on adding and subtracting radical expressions. So we're going to start here and clear up anything, see what you got right and wrong. This one right here, add, subtract radicals. This is where we're going to start. Okay. All right. We went over the odds, so you should have this sheet out on your desk. Okay? Got a pencil? This is add and subtract. That one's multiplying. You got 2 multiplying. 2. Okay. You want both, or can I take one back? Let me see if you got an add. I thought I'd give you an add because you were like missing some stuff the other day, but I've got extras. Multiplying radical, that's quizzes. Okay, let me get you an add. You got add and subtract? You guys were supposed to do those. How?
I've only got multiplying.
You only have multiplying too? Anybody else not have the add and subtract? Okay, multiplying. Everybody got add and subtract. You have a lot of quizzes.
Yeah.
Are they all the same or are they different?
Oh, I've already done the one that you gave us.
Okay.
So.
Well, I'm gonna clear up some stuff.
So you can have this copy back. I don't need it.
All right. Which one?
This one.
I have an extra copy of one of them too.
You do?
Yeah.
There you go. Okay. Sounds good. All right. So when I'm walking around here, I'm not saying a bunch of people actually did these yesterday. Do you guys consider Wednesdays like a free day to not do work? Okay.
No, I actually had to do one.
Yeah, do work. So we got to do the work.
No.
All right. So when we're adding and subtracting radicals, how do you know if you can add or subtract radical expressions? What's the telltale sign? Like terms, exactly. Now, when you're thinking about these, there's no x or variable or anything like that, but what has to be alike, and this won't zoom in the right way, what has to be the same is what's under the radical symbol. That has to be the same right here. And as you can tell on number 2, those are not all the same, are they? You have to make them the same. So that means you have to simplify before you can figure out if you can add or subtract them. Okay? So the answer to number 2 is D. But how did they get D? So I'm going to work this one for you. Well, you guys are going to help me. All right. Clearly, they're not all the same. And I would start on the left and start with the 2 radical 24. How could we change 2 radical 24? How could we break apart 24? This is my scratch work. Remember, when we're doing this, it's good to list our, what are these called? Perfect squares. And also the perfect cubes. Some of the perfect cubes, like 1, 8, 27, keep going down. Okay, so we're going to break apart 24. Do you see any perfect squares up there that will divide into 24? Yeah, you see 4 is a factor of 24. So I would start off by saying this would be 8 times 4, right? Then I break that 8 apart. 2 times 4. Break these apart. 2 and 2, 2 and 2. All right, so what I'm looking for are pairs. Pair of 2's is going to come out, and another pair of 2's is going to come out, and the last 2 is going to stay under the radical.
It's like that would be a 6 instead of an 8.
Oh, that's 32. Gosh, you guys. 6 times 4. Well, that is good. Good to know. There's a pair, and the 6, the 2 and the 3 don't get to come out, but they stay multiplied. So the pair of 2's brings 1 2 out, and it gets multiplied to this 2. So we got 4 radical, 3 times 2 stays under 6. We simplify 2 radical 24, it becomes 4 radical 6. 4 radical 6 minus 3 radical 6. And the next one is, how would you break apart 45?
8 and 5.
Say it again.
8 and 5.
8 and 5? That's
9
40.
and 5.
9 and 5. And guess what? 9's a perfect square, so that 3 comes out. So this is 3 radical 5. All right, so the only 2 that are alike that you can put together are the first 2. And you take the coefficient 4 minus 3, and you end up with 1 radical 6 minus 3 radical 5. And they don't write the invisible 1. They just write radical 6, 3 radical 5. Okay? All right. All right, number 4, the answer is B. The answer is B. Are we dealing with square roots or cube roots? Cube roots. So it's good to write down the perfect cubes. So I'm going to write down some perfect cubes for number 4 to get us started. Can I erase number 2? Or do you guys need all that still up there? Yes? No? Are we good? Still writing? I'm erasing a little bit here. My scratch work. Okay, McKinley, you got to keep me in line here. So that I don't miss add. Okay, let's go to number 4. I'm going to list some perfect cubes. So I've got 1. 2 times 2 times 2 is what?
8.
8. 3 times 3 times 3 is?
27.
And 4 times 4 times 4, anybody remember? 64. And 5 times 5 times 5? There you go. 6 times 6 times 6. I don't know that one off the top of my head. I'd have to do a little scratch. 96? No. 6 times 6 is 36. 3 times 6 is 18. And it's 216, isn't it? Okay. So I listed out some perfect cubes. Now clearly these 3 radical expressions are not the same. We're focused underneath the radical. This number has to be the same in order for you guys to add or subtract it. Okay? So they're clearly not the same. So how would we break down the first one? The negative cubic root of 40. How would we start that one?
8 and 5.
8 and 5. And guess what? 8 is on our list. That's perfect. So we're dealing with the first one. I'm going to do a little scratch work here. I'm going to keep my negative symbol. I'm going to break it down as the cubic root of 8 times 5. And I know 8 is a perfect cube. So the 8 will come out as a 2. And the 5 has to stay under. And that 2, that negative gets attached to that 2. And that's how you rewrite that one. Negative 2 radical 5. Okay? Let's do the next one.
Don't you need a cube?
Cube radical 5. Cubic root of 5. The next one is 2 cubic roots of 4. You can't break that one down. And the last one, minus 2 cubic root of 135. So we got to break down the cubic root of 135. How would we do that? What goes into that? What goes into 135? Does 5 go into 135? 2 is 10, 15, 3. So 23 times 5. Is that right? Is that math right? Does 5 go into 135? You guys have calculators. I don't have my calculator up. I should be checking that. Okay. They reduced this to 8 radical 5 minus 2,
It was only
8
27.
cubic root 27.
Because it wouldn't have worked. If
Gotcha.
I didn't have the 5, because 20 times 5 would be 100.
Right.
So
Okay.
I had to have that.
And 27 is a perfect cube. So it comes out as 3. 27 times 5, so that 3 radical 5, and we've got a negative 2 in front of it. So we multiply it to that, cubic root of 5, and that becomes, let me erase a little more here, down here, my scratch work. So I'm going to rewrite this so we can see it better. Negative 2, and negative 2 cubic roots of 5 plus 2 cubic roots of 4 minus 6 cubic roots of 5. And these two are the same, so they go together to get that negative 8 cubic root of 5. Their answer is their answer wrong or is our answer wrong? Do you see it? Right here? This is what they chose as their answer. They have a minus sign in front of this, when originally it was a plus sign. So their answer's off. It should be a plus sign, because there was nothing we pulled out to change that. We made mistakes too. There you go. So that should be the answer. Negative 8 cubic root of 5 plus 2 cubic root of 4. All right? Leave that up for a second. Number 6 on your worksheet. Let's see if I can get this to number 6. I keep saving all these pictures. I'll be full. This is the answer that they got. We need to verify that. So my first question is, can we add -2 square root of 24 plus 2 radical 2 minus 2 radical 8? Can we add those together or subtract them? Not unless they do what? Not unless they are like terms. Unless they have the number under the radical, the radicand, it has to be the same for us to combine them. So let's break down 24 again. We did it just a couple minutes ago. They've given us the answer, but we're going to break it down. Show our work. All right, so 24 broke apart as what? 6 and 4. 4 is a perfect square, so that 2 comes out. Now don't forget, we got a -2 out there. We have to multiply, and the 6 stays under. This 24 broke apart as 6 and 4. 4 came out because it's a perfect square. So that simplifies to -4 radical 6. 2 radical 2 is already broken down as far as simplified as far as it can go. And how about 8? That 8 under that radical. Can you break that down?
4 and 2.
4 and 2. So the scratch work on that one is 4 times 2. The 4 is a perfect square. It comes out and it gets multiplied to that -2. The other 2 stays under. So that's a -4 radical 2. Let me get rid of some scratch work. Okay. Now, do you see anything you can put together now? This one and this one. Plus 2 radical 2 minus 4 radical 2. Okay? All right? And that simplifies to that -4 radical 6 plus 2 radical 2 minus 4 radical 2. Their answer is different again, isn't it? Their answer different? You guys see a different answer? All right, maybe I feel like I have crickets in here. Cricket. All right. Do you guys see their answer right here?
Oh, that's wrong.
Right.
That'd be -2.
Right here. This is a -4 and a -2. This should be a -2. Wow. Whew. Boy, they keep us on our toes. -2 radical 2. There you go. This is the correct answer for number 6. Not what they have. Woo-wee. Okay. All right. You guys think you could do 8 and 10 correctly? Work on 8 and 10. I know the answers are up there, but you don't even know if they're right, because clearly some have been wrong. Work on 8 and 10 for a second. I need to respond to something real quick. 8 and 10. We're working on 8 and 10 for those that are at home. I can't respond because of my technologies. Not working. Okay. Let me see something. Okay. You get another. How do we break down 54?
9 and 6.
9 and 6. Is 9 a perfect square?
Yes.
So it comes out. All right?
Not a perfect.
Oh, we're doing cubes. Okay, so 9 times 4. Are there any perfect cubes that go into 54? Yeah,
27.
27 times 2. Okay, good. 27 and 2. Can't write on this unless I take a picture. Okay, so 54, cubic root of 54 is 27 and 2. This 27 comes out of the radical as what number? Was it 3? Okay, so the 3 cubic roots of 2. That's what that one simplifies to. 3 cubic roots of 2 plus a cubic root of a negative 2. Now, can you break down that negative 2? Does it have a perfect cube as one of the factors? It actually does. So I don't know if they'll do this to you on the SOL, but negative 2, if we were going to factor it, we could do negative 1 times 2. And negative 1 is a perfect cube. Negative 1 times negative 1 times negative 1 is negative 1. So it's actually a perfect cube. When you have an odd number in your index, you can have a negative perfect cube under there. There are negative, like negative 27, negative 8, negative 1. Those are negative perfect cubes. So that negative 1 is going to come out. Sure, I got this going. And underneath, we're going to keep the radical 2. So now we've got 3 cubic root of 2. Cubic roots of 2, 3 cubic roots of 2, plus a negative 1 cubic root of 2, which in this case, they got it right, leaves you 2 cubic roots of 2. They got it right on that one. Okay, but that's how that works. That's a good one to see. That negative 1, if you ever have this on the SOL, like cubic root of negative 1, it is negative 1. And also you can put it in your computer, your calculator, whatever. Okay, it actually does have one. Number 10 is pretty involved, but let's start breaking it down one at a time. I'm going to exit this screen for a second. I'm going to go to a different screen. I'm going to go, I got to update that picture. It's old. I'm going to go here. No. Let's do this. Okay. I'm going to rewrite this one for you. 2, this is number 10. 2 cubic root of 81. How do we break that one down? Cubic root of 81. All right, let's list some. Say it again.
9.
9 times 9. 27 times what? 27 times 3. Because we're looking for a perfect cube on our list. This breaks down to 27 times 3. 27 is a perfect cube. So it comes out from the radical as 3. Because it's 3 times 3 times 3. So it gets multiplied to the 2. And the other number has to stay under. Now let's deal with the next number. Next radical. So now we got minus the cubic root of 135. We just did this one, didn't we? How did we break that apart? 135.
27 and 5.
27 and 5. So this one is 27 and 5. We got a minus symbol, so we're bringing down our minus symbol. 27 comes out of the radical is 3. And the cubic root of 5 stays under. Okay, the next one is minus 3 cubic root of 2. I don't think we can simplify that at all. We can't, because 2 is not a perfect cube. So that stays like this. Okay. And the last one is minus 2 square root of 5. They're trying to trick you here. 5. Now, this is going to be a 6 radical 3, cubic root of 3. This is a minus 3 cubic root of 5, minus 3 cubic root of 2, minus 2 square root of 5. They have a misprint. Again, they misprinted. Okay, so looking across from left to right, we're looking under the radical symbol. First, we're looking at the indice, 3, 3, and 3, and then we look under here. You can't put any of those together, can you? Because none of them are the same. And this one has a square root symbol, so it doesn't even go with the others. It's like a totally different term. On their sheet, though, they accidentally treated this as a cubic root right here. This one. That impacted their answer. Okay. Breaking them down. Multiplying. Let's go to the multiplying worksheet. All right, hold on to those notes. We're going to multiply. So that key had some errors in it.
Yeah, I had a couple errors.
Yes, it did. Let's see what this key has. Does it have any errors in it? Now, I find multiplying radicals a lot easier. You just have to simplify them at the end, right? That's what the guy said. Go ahead and multiply them straight across and then just simplify them at the end. So, let's check it out. Let me do this. There we go. Number 2. Switching gears. Multiplying radicals. This worksheet. Number 2. Negative 2 square roots of 2 times 2 square roots of 5. What are you going to multiply first? Negative 2 and 2. What's negative 2 times 2? Negative 4. So that's our like coefficient out to the left. And then what are we going to multiply? 5 and 2, what do you get? 10. So it's negative 4 radical 10. And you break down the 10, 2 and 5. Are either of those paired when you factor those? No. So the answer is negative 4 radical 10. Their answer is correct. Okay, are there any questions on how to do that? Zoom in a little bit. So the answer to number 2 is A. Number 4, let's check the math. What are we going to multiply first? Unica, number 4, what would you multiply first?
4 and negative 2.
Gives you what?
Negative 12.
Negative 12. All right, let me screenshot this one because we're going to simplify some. Negative 12, you are right. Okay, and then you're going to multiply what times what? 20 times 10. So we've got negative 12 cubic roots. What is 20 times 10? 200. All right, now we got to think, can we break down this 200?
4 times.
4 times 50, 2 times 100. Let's list some perfect cubes. 1, 8, 27. Does 8 go into 200? 8's a perfect cube. Does 8 divide into 200?
Yes, 25 times.
25 times. So I'm going to break this one down as 8 times 25. The 8's a perfect cube, so it's going to come out as what? What is 8? 2 times 2 times 2. So it's going to come out as a 2. You guys understand what I'm saying? If you identify that one of your factors of this number is a perfect cube, we're dealing with cubes, you take the cubic root of 8, which is 2. It's 2 times 2 times 2. You're looking for triples. So the 2 gets to come out here. And when you bring the 2 out, you multiply it to the negative 12. Then you got the cubic root of 25. You cannot break down 25 anymore to pull something out. it won't happen, okay? It's not a perfect cube. It factors as 5 times 5, and that's a pair, and you're looking for triplets. So you go ahead and multiply these two coefficients to get negative 24 cubic roots of 25. And that is exactly the answer they picked. So they got that one right too. Phew. Any questions on that one? We'll move on to number 6. Any questions? Okay. No questions? Okay, let's go to number 6. Allie, what would you multiply first?
Negative 4 and 5.
And what would you get?
Negative 20.
Negative 20. And then you would multiply what?
6 and 10.
4, and what would you get?
60.
Okay, so let me erase some stuff here. And you're going to get negative, she said negative 20, radical 60. Now they have this is their answer, negative 40, radical 15. So I'm thinking we can tear that 60 down. Now we're looking for perfect squares here. So what can divide into 60 that's a perfect square? Yes?
15 times
15 times what? 4. And you picked 4 and 15 because 4 is a perfect square. 4 will come out of that radical as a 2. It will get multiplied to the negative 20. 15 will have to stay under the radical. And when you do negative 20 times 2, you do get negative 40, and 15 stays under the radical. So their answer is correct. Their answer is right. All right. Are we good so far? Number 8, they got 3 cubic roots of 4. Are there any coefficients we need to multiply? What's in front of each one of these radicals? An invisible what? Invisible 1. So we're good. So then we just take 12 times 9. What's 12 times 9?
108.
Now we're thinking perfect cubes. Are there any perfect cubes that divide into 108? They're 1, 8, 27, 64. Do any of these numbers divide into 108 even?
27 divides into 108 by 4.
By 4. So 27 times 4. So that 27 is a perfect cube. It's going to come out of the radical as a 3. 3 cubic roots of 4. Yep, their answer's right. You guys do the last one. I'll give you a couple minutes, and then we will, I'll tell you the answer. And I'll give you like 60 seconds to work on that one. I got a timer on here somewhere. Where's my stopwatch? There it is. Got a late start. So you guys are working on number 10. And I don't want to reveal the answer. Their answer could be wrong anyways. But you guys work number 10. Okay, anybody want to reveal their answer? We're at a minute 20. Anybody, Hunter? Did you get an answer?
Yeah.
What'd you get?
Negative 60. Well, yeah, indices.
What's under the cubic root symbol? What number? 2? That's what they got. You said negative 60, didn't you?
Yeah.
Okay, they got positive 60, cubic root of 2. So let's look and see who's right and who's wrong. The mystery. We'll solve the mystery here. So this negative 5, initially you think, I can't do anything with the 5. Yes?
I got 5 under the radical.
Like you got 60 cubic root of 5? Okay.
I got negative 60.
You got negative 60 as well. Okay. This is why it's positive 60. I'll show you. So this 5 can be broken down. It does have a perfect cube as one of its factors. The negative 5 can be broken down as negative 1 times 5. And negative 1 is a perfect cube. It's negative 1 times negative 1 times negative 1. So the negative 1's actually going to come out and get multiplied to that 3 that's sitting out there. So it becomes 3 times negative 1, which is negative 3. Radical. Oh, shoot, I broke it down first. That's fine. He taught you the different way to do it. I broke it down. I'm going to break down the negative 50 as well. I'm just going to go this route. And I'm going to pull out the negative 1 to multiply to the, you might be right, to multiply to the negative 4. Negative 1 times negative 4 is a positive 4. See? It's 50 breakdown. No. Negative 12. How'd you guys break down 50? Cubic roots. Cubic roots. Hang on. I'm getting something totally different here. Let's go back. Hunter, tell me what you did.
I don't even remember doing this worksheet.
You don't remember doing this. So you just saw the answer and you're like, I got this. Did- Okay. So we're multiplying. Negative 3 times negative 4. Negative 12. Cubic root. Negative 5 times negative 50. Negative 5 times negative 50 is that 2,500? 250. Okay. So can we break down 250? How do we break that down? 125 times 2, right? That's where it was. 125 is a perfect cube. So it's going to come out as a 5. So the negative 12 is going to get multiplied to 5. The cubic root of 2 is going to stay. And you're right, it should be a negative 60 out front. Negative 60 cubic roots of 2. Woo. Okay. Yeah. So it's better. I was trying to break it down, and no, just go ahead and multiply them straight across first and then break it down. Anybody have any more questions on how to add, subtract, multiply, and divide radical expressions? Okay, let's go to your module, which is where I thought I was. Let's look at things. Okay. Check for understanding, notes last week, add and subtract radicals, multiply radicals. We just went over those two. Have you guys done this yet? This is from last week's module, and I can move it into this week's. This check for understanding, which is delayed for me. Okay, let me do something to it. Let me go back. It should come up. Does it come up for you guys? If you go into the modules, go into week 27. Go into your module and click on that. It's under Thursday, February 25th. Check for understanding.
It loaded.
Is it low spinning?
It loaded.
It loaded for you. Okay. So I'm going to move it to my week 27 module. Week 28, sorry. Not at the top. I'm going to do it after this one. Move it. So it just got moved into this week. And then we've got these 2 quizzes that I'm also going to move into this week. And you guys got paper copies of those? Take out those 2 quizzes. Okay. And Delta Math and quiz. Okay. So if I go up here, go to this week's module. I've just moved the classwork check for understanding. You guys are going to do that. And then the 2 quizzes that I have here. I think you got paper copies last week, right? And you're going to work on those. Okay? Did you get paper copies? I know some of you are looking at me strange. Some of you weren't here last Thursday. I think at least one of you wasn't here that I know of. I'll have to give you a copy of these. But right now, you guys need to be working on this. It's Thursday. I'm going to change the date on it to reflect today. Thursday, March 4th. And that's what I want you working on. Okay, and then I'm going to change the date on the quizzes. So this is what we're working on right now.
Can I just give you these quizzes?
I was going to go over. I'm
Oh,
going to give you a couple minutes to do this, and then we're going to go over.
Perfect.
Okay?
So you're gonna go over the quiz?
Not the quiz, the tomorrow quiz. That's the one that gets submitted.
I got the tomorrow quiz from last week.
Yeah.
Okay. Then hang on to it. I'll collect it tomorrow.
Yeah.
But the other 2 quizzes, I want to go over the answers to. Do you know what I'm saying? Are you guys confused?
I'm confused.
Okay, last Thursday, I posted 2 quizzes. You just had to click on the links, right? And she gave you a paper copy.
The one you posted last Thursday was the same one that was posted this week for multiplying.
The adding and subtracting one never got posted. None of us saw it.
I did not post. Okay, let me see what I can. The one that expired, that was multiplying radicals. The one that expired was called multiplying radicals. While you guys are working on this, let me back up. Okay. So last week, the one that expired at the bottom, this one, that you had to do the code, and several people did it. I have the data from that. This one expired, but it was multiplying radicals. So that one is this add and subtract, multiply. Okay, I have this from you. I'm not sure why. Did you get another one? Maybe you turned it in last week. That was yours from last week. You want it? That's you give me the key. Okay. Notes, practice problems, multiplying radical expressions. Now, let me verify that this is the one. But you guys did you get a copy of this adding and subtracting quiz?
I didn't know. I got the, wait, no, I have the adding and subtracting, I don't have the multiplying.
The adding and subtracting quiz. Paper copy right here. Okay. Hey, did you get this, Hunter? Because it was given out on Thursday.
Well, then, no.
There you go.
I like to don't know everything looks the same.
I know. It also says quiz at the top. That's adding and subtracting, quiz.
I don't
You got it?
know.
Okay, now you do. So you say, yes, I have it now.
Yeah.
Happy to have it. Okay. And then trying to remember which one of these is the actual, because I made copies. Multiply, so this is this. Let me verify this really quick. I have to look. So I'm gonna, so those that are watching, I have to go onto my computer, so just hang tight for a second. I'm gonna exit this for a second. Okay. And then I actually think I have to exit the meeting. Let me see. Exit full screen. No, I don't.
We don't have to, if you're doing something with like grades or something, you'll probably have to stop the recording.
Yeah, I will. And I'll have to take this off. But I'm going into my quizzes to see which one is which. This matches that. This does not match that. This is that. This one is that one. Adding and subtracting. You guys should be working on that check for understanding. This goes with this. This one goes with this one. Make sure these are the same. These go together. This one goes here. I'm just going to make sure that you guys have the right. Now, you should have a multiplying radical expressions quiz. And question number 1 says negative square root of 2 times 5 square roots of 20. Everybody find this one. It says multiplying radical expressions.
I don't have that one.
And it says negative square root of 2 times 5 radical 20.
Do you want it?
Let me read it again. No. I just want to verify that you have it. Okay, the one that you should have says multiplying radical expressions, negative square root of 2 times 5 radical 20. If you don't have it, you don't have this one.
No.
Do you have, so come get it, because I got some. If you don't have that one, you need to come get it. This one. There you go. Anybody else not have the multiplying radical expressions that says negative square root of 2 times 5 radical 20? Everybody else has it. Okay?
Can I go to the bathroom?
All right. Adding and subtracting. All right, so let me verify something. This is the one that was posted. This one right here. Multiplying radical expressions. Hang on. Ignore. Okay, good. View quiz. This is the one that was actually posted last week. And you can see that really well, right?
Oh, yeah.
And the first question, what in the? What the?
Can you take it more than once?
No, it expired. That's why I was trying to get you a paper copy of it. What the? Okay, hang on. It is this one, and I can't reopen it. It has that little lightning bolt. View quiz. I want print the quiz. Let's see. It should look like this. Aha.
So they're both the same.
That is the quiz that was posted. Okay. This one right here. Make sure you have this quiz. Everybody have this quiz? Look at the screen. Everybody got that one? Multiplying radical expressions. If you don't have it, you need to get it. This one that you see on your screen, I'm hoping is the one that I sent to everybody. I'm pretty sure it is in the email. That's the one I'm collecting and grading. This one right here. The one you see on your screen is the one that gets the grade. That one. So if you don't have it, let me know right now. Everybody has this. John, you got it? Yes.
I don't think I have it.
You don't have it?
I don't.
You also should have it in an email I sent. I sent it on Monday, I think, to everybody. So if you lose it. For those that are sitting in the class, I'm going to collect this tomorrow from you.
These quizzes?
This one. Only this one.
So is this one not for a grade, the adding and subtracting?
No, we're going to go over that one.
Oh, okay.
I'm going to give you the answers to that one.
What if we did the multiplying one online?
This one?
Yeah. What if we did it
Do you
online?
remember your score?
I remember my school.
I do have the data of those that did it online. So you could do it again in paper, and then I'll take the higher score. I can pull up but I don't want to show everyone the data right now. Yes.
How will I type this in 3 radical 3?
Is this on the Canvas or is this Delta Math?
This is on Canvas. This is the check for understanding.
Okay, let me pull that up real quick because I want to guide you guys through
How do
that.
I type it in though?
How would you type that in? When typing your answers, 2 is typed as 2 square roots of 3. So you would, you got to write SQRT and then put 3 in parentheses. No spaces between the terms, which are the numbers, or the symbols or anything. The parentheses things. Okay, they make you type out square root, like they abbreviate it. That's a pain in the behind. Okay, so let me go here. Hopefully I can get into that. I'm going to get to March eventually on my little home page there. This is what you all should be working on right now. It's a check for understanding. Aha, comes up on here. Good. So this is what we're working on. Yes. Anybody got an answer for number 1? The first one. What'd you get? A, B, or
B.
Which one did you pick?
B.
B as in boy? Anybody disagree? You guys are just jumping down the rabbit hole? That's right. Good. This is the one you just asked me about, right? So on your keyboard, that you can't put in the square root symbol into this program. So they tell you to type SQRT. Whatever your answer is, like if it's 5 square roots of 10, you would type the number 5, SQRT, parentheses, 10. Make sure you close parentheses. And then submit. Okay? So you guys should be working on these. I'm not sure how many there are. Okay? And then I want to give you the answers to the add and subtract radical expressions. Being out for a week, you get all discombobulated quite easily. That's the one you should be working on. All right. So for those that are on the Google Meet, They're working on the check for understanding. And what I'm going to do is put up the answers to add and subtract radical expressions. Which was from last week, this one. I'm going to list the answers to that one. I'm trying to think how I want to do that. I know how I want to do it. Yes, sir.
This one is negative cube 3, but it doesn't say how to, that's square root, but it doesn't add any.
So what's your answer? What'd you get?
Negative cube 3.
Negative 1 CBRT, CBRT, and then, and what's under there? 3?
3.
3, let's see if this works. And then we go to submit. So negative 1, you said it's a negative out front?
Mm-hmm.
Oh, so yeah, you were right. Good.
Mm-hmm.
Is there any or just by himself?
There's an invisible 1 out there. Let's see, you're trying to break that one down. That would be 16 times 3. That'd be 4 radical 3. Okay.
So there is
Mm-hmm. Yeah. Putting up the answers to the adding and subtracting radical expressions. From last week. All right. So what? Oh, you don't see it. What the heck? What, in the meeting? Yeah, in the meeting. Huh. Hang on. I'm just putting up the answers to that. And oh, they do see it. There it is. Okay, just had to change my screen. So you did have a worksheet last week. It said quiz and it said adding and subtracting radical expressions. And it looked like this, adding and subtracting radical expressions. These are the answers to those. Okay? So you're doing your check for understanding. You're looking at the answers to the adding and subtracting radical expressions. And if you have a question on any of those, now's the time to ask. You cannot add radical expressions that don't have the same radicand, meaning square root, and underneath it has to be the same. Multiplying is fine. You just can't multiply squares times cubes. Square roots times cubic roots. So that quiz that from last week is expired. It expired. It expired. That's why you can't get in it. I just got an email. Somebody tried to log into it. It has expired. That's why I sent you an email with it for those that are virtual. And I gave you guys a paper copy. That multiplying radical expressions has expired. I'm not going to go back and redo it again. It's a pain. So that's why I sent you a copy. Yeah, I just got an email at 8:21 that someone tried to log into it. It's done. That's really the only thing that does expire. The Delta maths don't expire. They code to red once they're late, but they don't expire.
Yeah, you can't get in when they're red.
What, you can't? Yeah, you can.
Well, you can get in when they're
Green and red.
yellow, but I can't get in when they're red.
Bring your computer to me. Because I click to forgive lateness all the time. So what it does is if you do it late and then I pull your name up, you've told me you did it, I pull your name up, it'll have your score as a 0 until I click to forgive lateness.
All right.
You see them? Yeah, there's been some students that are like, I can't get in this. And I'm like, we are coming into the home stretch. I'm like, I know you can get in those. The only things that expire are these quizzes. They just force us to put a due date, and that's when they're done. So that's why I sent out an electronic copy. Okay. I want to take a look at your check for understanding with you guys. So, all right. What do you get for an answer on this one when you simplify it? Atticus. Say it again. 3 radical 3. So the 48 breaks down to 16 times 3. So you pull out a 4. So now you got 4 radical 3. And let me screen. Oh, I'm on here doing this because it won't go on that one. So this becomes 16 times 3. The 16 is a perfect square. It comes out. So now it's 4 radical 3. And this is 4 times 3. So that comes out as a 2 radical 3. And that's 9 times 3. And the 9 comes out, because it's a perfect square, as a 3 radical 3. And you said 4 plus 2 is 5, take away 3. So 2 radical 3 is correct. Yes, that's what you would type in there. Any questions? This is a pretty simple one. I could see them putting this on the end of the year test. Any questions on how to do that? That's square roots.
4 plus 2 is 6.
Say that again.
4 plus 2 is 6. You said 5.
4 plus 2 is 6. Take away 3. Oh, 3 radical 3. Yes. McKinley, I don't know what I would do without you. I need you to check my bank account because I could be way off. Yes. Yes. Whew. Okay. So we said that was what? 3 radical 3? So I type in 3 square SQ T parentheses. This is quite a chore, right? There we go. I'm just following the rules here. Okay. All right. So these two, when they're combined, they're both cubic roots. So we're thinking our perfect cubes are, what was that? 2764? Is that right? Okay. So this breaks down to 8 times 2. So the cubic root of 8 times 2, 8's a perfect cube. It's going to come out as a 2. So now we got 2 cubic roots of 2. The next one is 27 times 2. This one? 27 times 2. So that one is 27 times 2. And that's a 3. That comes out as a 3. 2. And then I combine the 2 and the 3 for 5. Make sure my math is right. 2 plus 3 is 5 cubic roots of 2. That's what you would type in. Or that's what you would pick. 5 cubic roots of 2. So C. Hopefully I'm right. All right. Next one. Anybody got the answer to this one? How many are there? Do we know? I don't even know how many there are in this guess and this check for understanding. All right, who wants to break this one down? Sean, break down this first radical for me. How would you break that down? How would you simplify that? Okay, they're up there. So how would you break down the 24?
8.
Uh-huh. And what?
2.
8 times 2? 8 times what is 24?
3.
Okay, so 8 and 3. And 8 happens to be a perfect cube, so it gets to come out. And what happens to the 2 that's already out there?
It just gets multiplied.
Those get multiplied. So now we're looking at 4 cubic roots of 3 for the first one. This one is not broken down. There's a perfect cube that goes into this breaks down to what? Negative 1 times 3. So we've got plus 2, and that's negative 1 times 3. So the negative 1 comes out of the cubic root symbol as a what?
1.
It comes out as a negative 1 because it's negative 1 times negative 1 times negative 1. And it gets multiplied to that 2. And under the cubic root symbol stays the 3. And we got minus. So we've got minus 2 cubic roots of 3. And then how about 81? That's got a cubic root under there. What times what is 81? 27 times 3. So this is a minus cubic root of 27 times 3. The 27 is a perfect cube, so it comes out as a 3. And the other 3 has to stay under. And now they're all the same, so we can combine the 4, take away 2. 2, take away 3 is negative 5. Is that right? 2, take away 3. 2, take away negative 1. Cubic root of 3. 4 minus 2 is 2. 2 minus 3 is negative 1. Cubic roots of 3. Do you guys agree? These are, yes.
There are 8 questions.
They're 8. Thank you. We got to wrap it up. So it's negative 1 cube root CBRT of 3. All right, hopefully I typed that right. Okay. All right, so this check for understanding, you guys should be able to do these. That's the expectation. Okay. That paper quiz, multiplying radical expressions, I'll collect that tomorrow. And And I'll have something else for us to do in class tomorrow because I feel like I'm doing all the legwork here. You guys are good. I've taught it. You guys should be able to practice it and show me that you got it. So we'll do that tomorrow. We'll do probably maybe some Kahoot and something else. Okay. So don't lose things. Bring this. I want your paper copy of this tomorrow. This quiz. Okay. Got it on my list of things to do. Multiplying. All right, I'm exiting the meeting for those that are on the meeting. I am exiting.